I'm going to demonstrate how to fill out Pascal's triangle. It's the same pattern over and over again. This triangle does go on forever. I'm only going to fill it in until row 6, but it is the same pattern over and over again, so you could continue on as long as you wanted after I am done with my triangle. First things first, you are going to put ones all down the sides of your triangle as an outline. So the top is just a 1. The next row has 2 ones next to each other. And then as you go to each next row, you have them a little wider because we're going to fill in between those ones. So the top row is 1. The row after that is 2 ones right next to each other. Now is when you have to start filling in everything else. Once you have 2 numbers that are next to each other, what you do is add them together and put that sum in the space below those 2 numbers. So in that second row, in row 1, I've got 2 ones right next to each other. So I'm going to add them and I get 2, and I'm going to put that into the next row. So the next row would be 1, 2, 1. Now I have a row of 1, 2, 1, where I have 1 and 2 next to each other and 2 and 1 next to each other. So I'm going to add those. And this is the same pattern the entire way. So now I've got 1 and 3, that equals 4. 3 and 3, that equals 6. 3 and 1, that equals 4. So this will always be symmetric. Once you get towards the middle of the triangle, you're going to repeat the pattern backwards to get to the end of that row. So the next row, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5. My final row, I've got 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 15 is 15, 5 and 1 is 6. And like I said, this goes on forever. Now, the purpose of Pascal's triangle is it gives you a shortcut in expanding binomials. An example of a binomial is x plus 2 or 7x plus 7. It's an expression with 2 terms in it. So this would be an example of something that I can use the binomial theorem on to expand it. Instead of doing x plus 4 multiplied by itself 6 times, that would take you forever. So the Pascal's triangle is a shortcut in doing this. But for this video, I was just demonstrating how to write out the triangle. I will demonstrate examples where I actually use it in other videos.